Okay, what we have here is the 7.3b, which is 6.6 worksheet. I think it's from Prentice Hall. Practice Form G, Trapezoids and Kites. So let's see what we have. So, find the measures of the numbered angles in each isosceles trapezoid. So they're telling us that these are isosceles trapezoids, so we know it has, if it's isosceles trapezoid, it has congruent base angles. The diagonals are going to be congruent. We got the legs congruent. Might have to do alternate interior angles, stuff like that. So let's see what we have. So if this is the leg and this is the leg, number one is going to be a base angle, and the base angles need to be congruent. So that's going to be 96 degrees. Altogether these have to be 360, so we could do two 96s, and then these are going to be congruent at the top and solve that way. Or we could do parallel lines cut by a transversal, where one of the legs is the transversal. Same side interior angles need to be supplementary. So if I do 180 take away 96, I get 84. So angle 2 is going to be 84 degrees. Angle 1 is going to be 96 degrees. That means this other angle over here is going to be 84, and altogether 2 84s and 2 96s should add up to 360 for the polygon sums for a four-sided polygon. So look at number 2. So here, this trapezoid's kind of turned on its side. Here's the congruent leg, here's the congruent leg. That makes 2 the base angle, and this angle here is the base angle. So we got 279s. Again, parallel lines cut by a transversal. Same side interior angles are supplementary. 180 take away 79 is going to be 101. So angle 1 is 101 degrees. Angle 2 is 79 degrees. So look at number 3. Here are the congruent sides. That makes number 1 the base angle, and together these are same side interior angles. They need to be supplementary. So 180 take away 67 is going to be 113. So angle 2 is 113 degrees. Angle 1 is 67 degrees. Let's move up. Okay, let's see. Congruent base angles. Here's the isosceles legs. Here there are the isosceles legs. That means 3 is going to be 55 degrees. Together we have same side interior angles supplementary. 180 take away 55 is 125. And this other angle also has to be congruent. It's going to be 125 degrees also. Let's look at number 5. Base angles are up here. This angle at 3 is also going to be 135 degrees because it's isosceles. And then same side interior angles supplementary. That leaves angle 1 needing to be 45 degrees to make the 180 same side interior angle pair. And because of congruent base angles in an isosceles triangle, angle 2 is also going to be 45 degrees. Let's look at number 6. So isosceles makes 1 base angle, so it's going to be 85 degrees. Together, same side interior angles need to be supplementary. It's going to take another 95 degrees to make 180 for this linear pair. Well, not linear pair, for this same side interior angles being supplementary pair. And that means angle 2 is also going to be 95 degrees. Let's look at the next one, number 7. 47 is a base angle, 3 is a base angle. 47 degrees goes with angle 3. Same side interior angles are supplementary. 180 take away 47 is going to be 133. So angle 2 is 133, and then because it's isosceles, angle 1 is going to be 133 degrees also. Okay, now some algebra is going to be involved in this, so let's see what we got. Find the values of the variables in each isosceles trapezoid. Okay, so there, this side is congruent to this side. Therefore, 3x minus 3 equals x plus 5. This is just extra. Well, actually, if we were doing stuff with the bases, then we could you find the length by doing the average of the bases. But what we got right now is take x away from both sides, 2 x's, add 3 to both sides, gives 8, divide by 2, x is equal to 4. That means this is going to be 12 take away 3, which is 9, and this is going to be 4 plus 5, which is 9. They want us to find out what x was. Okay, let's look at number 9. They're telling us that this angle is 6x plus 20 degrees, and this angle down here is 4x. So together these are in same side interior angles. Here we got the parallel lines. There's the transversal. Got kind of this pattern here. Here's parallel, parallel. These angles are going to be supplementary, same side interior. So we have 6x plus 20 plus 4x equals 180. So that gives us 10x's plus 20 equals 180. Take away 20, 10x's is 160. Divide by 10, x is 16. So x is 16 for these. And y is going to be the same thing as, or the same measure as the 6x plus 20 angle. So if x is 16 degrees, 6 times 16 is 96. 96 plus 20 is 116. So you got 6 times 16 plus 20 equals 116. And y is also 116. So y equals 116. Okay, for number 10, we've got 2 isosceles legs, 2 sides are congruent, so we set 7x equal to 2x plus 5. Take away 2x from both sides, 5x's is 5. Divide by 5, x is equal to 1. That means this is going to be a 7, and that's going to be a 7. Okay, here we want to find the length of xy in each trapezoid. So with these type problems in a trapezoid, the average of the 2 bases, or add the bases, divide by 2, that's going to be the middle segment length. It's half, if you add these up, the mid segment length is half the sum of the bases. So we have problems involving that. And also, let's see, yes, the average of the lengths. So also these segments are going to be congruent because x and y would be the midpoint. So that might be coming up. So what we have to do to find out the length of xy here, we're going to add 5 and 2.5. And then we're going to divide by 2. So that gives us 7.5 over 2, which is 3.75, or 3 3/4 if you go for fractions. Let's look at number 12. They want us to find xy. That's going to be the average. So again, the formula we're using is base 1 plus base 2 divided by 2 equals the mid-segment length. So that's what we got. So 8 and 6 is 24, or 16 and 8 is 24. Divide that by 2, 24 over 2 comes out to be 12. This one was 3.75. And let's look at the next one here. 15 and 6 is 21. And 21 divided by 2 is 10 and a half. or 10.5. So get number 14. So find the lengths of the segments with variable expressions. So now we got algebra involved, but basically the idea is base 1 plus base 2 times a half, or divided by 2, is going to be equal to the middle length. So we've just got some algebra problems to do here and simplifying like terms and stuff like that. So we got 1 base x plus 16, base 1, plus base 2, which is 2x minus 5.5, is equal to the middle segment, which is 2x plus 0.75. And again, remember, we're doing a half of that is going to be equal to the mid-segment length. So combining like terms, we've got x and 2x makes 3x. 16 take away 5.5 is 10.5. And remember, we're multiplying by half, so the same thing as divide by 2, and that's equal to 2x plus 0.75. Gotta get rid of this 2 in the denominator and get, so we can bust this loose and then get our x's together. So plan, multiply by 2, it's going to give us a 4x, take away 4x from both sides, move the 10.5 over, and see what we get. So multiply everything by 2, that cancels this out on this side. We've got 3x plus 10.5 equals 4x plus 1.5, because we have to do 2 times each part over there, so 4x plus 1.5. Now we're going to take 4x's away from both sides, so minus x on the left equals, and we're going to take 10.5 away from the right, so 1.5 take away 10.5 is going to be a minus 9. 10.5. It's going to be a minus 9. So minus x equals minus 9. X is going to be 9. Now they want us to find the length, so not just x. We got to plug this number back in. So FG, let's do these on the left. FG's length is going to be 9 times 2 take away 5.5, which is 18 take away 5.5, which is 12.5. AB is going to be 2 times 9, which is 18, plus 0.75. So this will be 18.75. And XW is going to be 9 plus 16, which is 25. So if we kind of look mental math-wise, 25 and 12.5 is 37.5. Half of 37.5 is 18.5. So it checks out. This is half the length of those two added together. Let's look at number 15, same idea, 2x minus 4. Let's do this vertically. Plus 3x plus 2 has to equal 2x plus 4. And again, we're going to do 1/2 times whatever this comes out to be. So half of 3x and 2x is going to be 5x. And we have a minus 4 with a plus 2. This is going to be a minus 2. But we got the 1/2 times it, so this side's going to give us 5x minus 2 divided by 2 is equal to 2x plus 4. Double both sides to get rid of the 2 in the denominator. We have 5x minus 2 equals 4x plus 8. Add 2 to both sides, take away 4x. X equals 10. Now if x is equal to 10, we got to find the lengths of the sides. 20 take away 4 is 16. 20 plus 4 is 24. Now we could figure out, since this is half the distance of these two added together, 16 plus x divided by 2 equals 24. 16 plus x is going to be 48. X is going to be 32, or this is going to be 32. Let's see what we get. 3 times 10 is 30, plus 2 makes 32. And 32 and 16 is 48. Half of 48 is 24. So we found those. It's 32. And let's look at the last one here. Same thing. These two added together divided by 2 is equal to this. So I'm going to kind of shortcut this a little bit. Notice we're multiplying by 2 all the time. I'm just going to go ahead and double this one. I'm going to make this 8x plus 15, and that's going to be equal to 8x plus 3 plus 4x. So we had to divide by 2. I just went ahead and multiplied the right side by 2. Just skip that step. Combine like terms, 12x plus 3 equals 8x plus 15. Take away 3 from both sides. Take away 8x from both sides. 4x is 12. X is going to be 3. Now if x is 3, we get 24 plus 3, which is 27. If x is 3, 4 times 3 is 12. 27 and 12 is 39. 39 divided by 2 is going to be 19 and a half. This is going to be 19 and a half. Let's plug it in and see. So we got 3 in here. So 3 times 4 is 12. 12 plus 7.5 is 19 and a half. So it checks out.